Hi, this is Suey778 coming at you with yet another multimeter review, and today's flavor is the Kaiweets HT112B Smart Digital Multimeter. And this is also a first on this channel, as this particular multimeter was sent to me by the manufacturer for a review. I do want to say before we get any further that this is not a sponsored video. I am not being paid to do this. The manufacturer simply just sent it out to me for me to review and give my fair, unbiased opinion of it. So I do want to say thanks to Kimberly for sending this out. And without further ado, let's go ahead and do the unboxing. As you can see, you got a nice looking box here. Not a whole lot on it. Few things. Okay, and first we do have the user manual. Hopefully you can see that. Some more specs for you there. I believe that's all of it. And of course we have the meter itself. Nice little semi-hard case. And inside we get, I'm going to have to hold this up because this is kind of small. This thing is shaped like a small cell phone. You get some leads. Also, it comes with 4 CR2032 battery cells. 2 of them are missing because I've already put them into the unit. And also, we get a spare fuse, so that's pretty cool. We're going to go ahead and stick that back down in there so we don't lose it. And then, of course, you get the multimeter itself. And let me bring that up to the camera real close since it is kind of small. And try to get the glare out of it. And there you go. All right. Okay, and now for the overview of this unit. As you can see, it's got a really big screen that pretty much dominates the face of it, and 4 buttons. You get your power button, your smart/function button, select and flashlight, and your hold button, which is a freeze frame, and the backlight controls. This is a 6,000 count meter. Does use 2 CR2032s as I mentioned previously. The probes are proprietary in the sense that they are not the standard jack size. They are actually smaller. And just to show you a comparison of that, I'm going to bring in, here is the HT100Bs, and here is the Probe Master. As you can see, considerable difference. So while it is modular, they also are proprietary in their size. Okay, this is a 6,000 count multimeter, and it does have a backlit LCD. It does not stay on. However, it does, when you light it up, it does remain lit for 2 minutes before it goes off, so that's pretty decent. The protection on this, I would basically call this a category 2 250 volt multimeter. This also, according to the manufacturer, is intended as a replacement for the HT118A. We'll assess that as well. Let's go ahead and turn it on to show you what all it has. So you have to press and hold. And as you can hear, it's got a high-pitched beep. And as you can see, this multimeter does have an auto mode, and you can see the little dial going up between it. Basically, this will pick up automatically on DC and AC voltage, resistance, and continuity. And then for your other functions there, let me show you the backlight. Actually, a quick press will give you the hold. Long press will give you the backlight. Okay, there we go. And then to get out of the smart function, you just hit the smart function button. This will take you up. So here we have AC/DC millivolts, hertz and duty cycle, capacitance, diodes, microamps, and the lead warning is basically saying that your leads are not in the correct jacks, so that's a handy feature. And by the way, when you do put this in current mode and you have the leads connected correctly, it will only let you toggle between microamps and milliamps. It will not let you go anywhere else. So that's a nice built-in safety feature. And last but not least, NCV and live. Also, you can see here on the, and then just push the button again to put it back into auto mode. You can also see that we have a temperature display. It does show it in Celsius. This meter has no thermal probe feature. Basically, this is just a built-in thermal probe feature that will display the ambient temperature. Okay, let's go ahead and we'll get to the take a look at the battery compartment and do the teardown. Okay, so to get to the battery compartment, we have to take the glove off, so we'll do that now. This is actually pretty easy. It probably looks harder than it really is because I'm standing behind a tripod right now trying to get it taken apart. So give me just a second here. There we go. See, it comes right off. Get that all the way. And on the back here we have, let me just lay it down here on the table. Zoom in just a little bit. As you can see, the battery compartment is right there. Just need a small screwdriver. I didn't get it enough. Comes right out, and as you can see, we get our two PK cell batteries. And then to take the rest of this apart, I'm going to try to do this. Actually, probably should take the batteries. No, let's try to do it with the batteries on. As you can see, this comes out pretty easily. This actually turned out to be a lot easier to tear down than I ever imagined it would be. I figured this one was going to be kind of a pain to get into. Nope, not really that hard. Okay. And basically, you need one of those guitar pick things. And you just slide it like so. There we go. And it just comes right off, and of course the batteries decided to land on the PC board, which is not a good thing, and that's alright. And there we have it. Let me get this set up and we'll go over the PC board real quick. Okay, now that we got this set up here, close up, to the left here we've got a single PTC. We've got some resistors up here. Looks like some more resistors down here. This is actually the relay for the auto control. Your single 600 milliamp fuse. I am assuming this is 250 volts. It does describe the fuse here, but it doesn't really say. It just says that it's 600 milliamps. Anyway, connectors are down here and going, into here. That looks like it's fairly solidly built. Your battery contacts are here. You're got some diodes here and some more resistors and diodes up here. Here is your main processor. We can actually see that, I believe. But basically this is an SDIC SQSW processor, or IC, I should say. Down here looks like the controller for the LCD display. Here is the LED for the flashlight. Your NCV is up here. It looks like the calibrating terminals appear to be right there. And that's about it, really. Fairly simple design. Again, I would definitely call this a category 2 250 volt multimeter. Protection on this I would class as minimal. Basically just meant for bench work. But anyway, let's get this put back together and then we'll start doing some tests. Okay, now that we got that put back together, there is one thing I did neglect to show you, and that was the jacks. They're located on the bottom of the unit, as you can see here. That's your common, that's your milliamps, and then that's for all the other functions like capacitance, resistance, voltage, etc., etc. And last but not least, let's go ahead and de-virginize it. I know this is, some of y'all are frothing at the mouth for this, so here we go. Voila. Ooh, boy, that's real shiny too, isn't it? Look at that. Wow. Okay, well anyway, the Kaiweets HT112B is officially de-virginized. Let's get set up and do some tests. Okay, we're going to start off the testing in the auto mode. So this will include DC and AC voltage, resistance, and continuity. We're going to start off with the voltage standard. So I've got my UT8804N patched in along with it, and of course the HT112B. So let's go ahead and get this plugged in and let's see what we get. This is 2.5 volts and we're getting 2.503. There is something weird here. As you can see there, it jumped up to 2507, 2506, and then it'll jump back down to 2503. This seems to be a quirk in this particular meter. As you can see, the reference meter is holding steady, you know, at 25007. But this one is traveling around a little bit. We're just going to assume that the lowest value is what it's actually reading. I don't know if this has something to do with the auto mode, but I've never seen a multimeter do this before. Let's go to 5 volts. And we're getting 5.013. That's the low value. And again, it's drifting up, as you can see there. That's a little bit annoying, actually. Okay, let's go to 7.5. And this meter, again, reading 748, but drifting up to 7.51 intermittently. Yep, that's what it's doing. It's still pretty good. I mean, you know, the readings aren't bad. It's just that drifting is, that's distracting. Okay, let's go to 10 volts. And as we can see, it's reading 9.99 volts, which is pretty close. And then up to 10.01, 02, and then it'll drop back down to 9.99. Yep, does that. All right. Let's go ahead and go for the 32 volts here. Hopefully this is going to make it over to my power supply. I have to be a little bit careful here. Okay, looks like we got just enough. Oh, need to turn it on. That might help. There we go. This is 32 volts. And as you can see, it is reading 32.01. But okay, the 3198, 3199 is what we're actually getting. And then it is sliding up to 3201 again. So it's doing the same thing. But again, I would say that this is an accurate meter. But that drift, and I'm assuming that's got to have something to do with the auto mode, because in millivolts, it won't do it. In fact, let me turn that off and let's put it in millivolts. Okay, had some technical difficulties there. I do have it patched in here on the millivolt scale on both of these meters, and as you can see, in the millivolt range, this one is not doing exhibiting the same behavior that it was in the volts range. It's pretty much holding true. Yeah, and its millivolt readings are, pretty close to what my reference meter says. Have absolutely no problem there. So for whatever reason, the volts range has that quirk in it. And we'll touch on that at the end of the video. Anyway, let's move on with the test. Let's go to the AC voltage here. Let me get this turned off. Let's get these unpatched. And by the way, yes, I did try measuring it separately and got the same exact thing happening. So let me get these out of here. As you can see, I had to get really creative about doing this. So let's go ahead and get this turned on. Let me see if I've got that in the camera. Yeah, it's in the camera. Okay. Let's get that backlight back on. And let's see what we get in the volts reading here. And we got a train going by. That figures. Let me put it back into auto mode actually. There we go. And here we go. And we are getting 123.1, and it is showing a duty cycle of 60 Hertz. So that looks good. And as you can see, it's rock solid on AC voltage too. It's just that DC voltage that has that little issue. Let's go ahead and try the Hertz on this. Let's go to the Hertz and duty cycle, and let's see what we get here. And it looks pretty good there. You get the 2 decimals there, so that's nice. 60.05 and then 49.8 on the duty cycle, so I would say we're good there. And we'll do the frequency test on this later. Okay, now we're going to go ahead and do the continuity test, continuing the tour of the auto mode. So here we go. Not particularly fast, but once it latches good. So I'd say that's fine. Also, one thing to note on this, in the auto mode, since continuity is shared with resistance I should say, this will give the continuity tone up to 50 ohms even when you're measuring a resistor, just so you know. This first resistor is 10 ohms, so we should get a beep, and we do. 10.4 on the reading, so we're good there. Next is 100 ohms. Looks good there. Next one is 220, I believe. Looks really good there. In fact, it's pretty much right on. Next one is 330. Looks really good there. Okay, next one is 1K. Looks good there. 2K. Looks good there. 5.1K. We get 5.12, 5.130. Okay, looks good there. 10K. Right on the nose. Nice. Okay, 100K. About what I expected to read there, so looks good. And then finally 1 meg. And that looks good there. Okay, I'll throw in the resistor box real quick. And we'll do a, it's going to beep when I put these leads in, so you have been warned. And he gives the usual resistance. Okay, so let's try 2 megs here. Okay, about what I expected. 4 meg. Right what I expected there. Good. Let's go to 10 meg. And we are getting, let it settle here, 9.9796. Okay, looks good there. Let's go to 11. Taking a little while to get up there. Should get around 10.97, 10.98, and we are getting 10.97, so looks good there. Okay, next up we're going to do some capacitance. Got my capacitance box here, so let me go ahead and get these hooked up. This meter does not have a rel feature, by the way. Okay, we're going to try 100 picofarads. I don't think this is going to be able to do it, but we're going to give it a shot. Let me get it in the right mode first. That would probably help. There we go. Okay, yep, it's not reading that correctly. Not reading that correctly, and actually, I think this is 1 nanofarad right here. The picofarad range is pretty much a no-go on this one. Looks okay at 1 nanofarad. 1.5, yeah, that's about right for that one. That one comes in a little bit low. 2.2 looks good. 3.3, low as expected. All right, let's go up to the higher range on this box. So here's 4.7 nanofarads. That looks pretty good. Let's go up to 10 nanofarads. Looks good there. 22. Oh, that's 15. I'm sorry. Yep, that's right. 22. Looks pretty good there. 33. High as expected. 47. High as expected. 56, this should be low, and it is. 68 should be around 64-ish. Yep, looks about right to me. And then 100 nanofarad should be around 102, and we are getting 103, so no problems there. That works just fine. Okay, let's bring the PCB board back in. Let's measure a few bigger capacitors. Okay, here is 1 microfarad. Okay, looks good there. Let's go to 10. Kind of slow on capacitance, but yeah, that looks about right there. All right, let's go to 100. Looks good there. Let me get that light back on. Okay. Let's go ahead and try the 470. This should come in around 410, 405-ish, somewhere in there. And we're getting 408.6. Looks good there. All right, 1,000. 1,000 microfarads. Should get about 950-ish. Yep. Looks good there. Okay, 2,200 microfarads. Let's see if we can get Mr. 2,200 to cooperate today. Kind of slow. 2.096. Yep, looks pretty good there. And last but not least, the big one. Probably going to take it a while. Should be around 950 to 975. And we're getting 9.627 millifarads. Okay, yeah, it looks pretty good there. So I would say pretty good on capacitance overall. Just remember the low range on this is 1 nanofarad. And I believe this goes up to, I'd have to look at the specs. I know it goes up to at least 20. It might go higher than that. Anyway, let's go ahead and switch over to diodes. Start with the lights, the LEDs. So we get red with reading, yellow with reading. As you notice there, the light is blinking. I'll explain that here in a second. Green with the reading, blue with the reading, and white with the reading. Looks good. And we'll do the RGB. Red, green, and blue. All with readings. So it looks good there. Okay, let's go ahead and do some regular diodes. Here is the rectifier. 560. Looks good. Fast recovery. Dot 521 looks good, and we are getting a continuity beep, so that's nice. Schottky. 203, 202, looks good. Switching. 621, 620, okay, looks good there. And the germanium. 287, slightly high, but that's fine. Okay, so here's the interesting thing about this. Let me grab the HT118A here, and we're going to test the output voltage, and we're going to show you something interesting as well. Okay, let's go ahead and measure the output voltage. We're going to use the HT118A here, and I want you to pay attention to what this does. Let's go ahead and put these in here. As you can see, we get a very, very, very healthy 3.94, almost 3.95 volts. But as you notice, it is cycling about every 4 or 5 seconds. And I'm assuming this is a feature to help save on the batteries. And that's why the diode, the LED lights were going out intermittently, as I showed there. In fact, we'll show that again here. Now, this doesn't adversely affect the readings or anything like, well, let's just do the red here as an example. As you can see, we're getting a reading just fine, but every once in a while it'll go out. But we don't lose the reading when it goes out. But yeah, that's just something to be aware of. And I did watch other videos of this just to make sure that mine wasn't brain damaged, and sure enough, theirs was doing it too. So anyway, interesting that it does that. Very nice output voltage though, in any case. Okay, here we go with the DC current test. We're going to start off, got my lights and everything hooked up here, so we're going to start off with our usual 5 milliamps and work our way up. As you can see, when this thing is connected and there's nothing going through it, it beeps and beeps and beeps. So let's get this turned on so it'll stop doing that. So here we go. Okay, lights came on, 5 milliamps, and is reading a little bit high as expected. Not quite as high as the other meters do. It's reading at about 5.8. Okay, let's go up to 10 milliamps. And we are getting 10.6, 11.2. Okay, looks good. That's about what I expected to see there. Get that light back on. All right, let's go up to 20 milliamps. Okay, and we're getting, let's give it a chance to settle here. Yep, 21, so looks good there. And again, for those of you new to the channel, my power supply does tend to overshoot about 1 to 2 milliamps on this test, so this is normal. So what this is reading is about what it should be. All right, let's go up to 50 milliamps. Okay, give it a chance to settle again. Light's getting nice and bright, and we're getting about 51.2, 51.3, so that looks pretty good there. All right, let's go up to 100. Okay, there's 100. Again, let's let it settle. And it's actually reading it right at about 100. A little bit over. Okay. All right, let's go ahead and try 150. Okay, and that is putting it up to 150, a little bit over, going high. I would say pretty much right in the ballpark of what it should be. This was actually reading a little bit lower than most of my other meters do, but it's still well within, well within spec, I would say. Okay, here we go with the test for the HT112B. In the manual, it states that the range of this meter is 10 Hertz to 10 megahertz. So what we're going to do is we're going to start at 1 Hertz and work our way up. We're going to be using an amplitude of 2.5 volts for this one. So let me go ahead and get the backlight on so you can see what's going on here. I do have it zoomed in a little bit. Let's go ahead and start. This is 1 Hertz. And we are getting 0.998. Duty cycle looks okay. All right, let's go up to 10. Okay, looks pretty good there. All right, let's go to 100 Hertz. Looks good there. Let's go to 1K. And it looks good there. All right, let's go to 10K. Looks good there. Duty cycle is holding steady. We are using a sine wave, by the way, like we always do. Here's 100,000, or 100 kilohertz, I should say. Looks good there. Okay, let's go to 1 meg. Okay, looks good there. All right, let's go to 5 meg, 5 megahertz. Looks good there. Duty cycle dropped a little bit. A tiny bit high, but no big deal. All right, let's try going to this machine's full spec, which is 10 megahertz, and it's picking it up just fine. All right, let's go ahead and go to 11. Looks good there. 12. Looks good there. Let's go to 15. Looking good there. So we're over spec by 5 megahertz. That's nice. Okay, let's go to 20. Yeah, not quite getting 20. Let's try boosting up the amplitude to 5 volts, and let's see if we can get it to work. And it does work. Look at that. All right, well, let's try to keep going. Let's see how high we can go on 5. Okay, there's 21. Yeah, it won't do anything above 20. Still though, it's 10 megahertz above spec. So for this test, looking pretty good. The actual range on this is 1 hertz to 20 megahertz, which is well beyond specs on both sides. Okay, last thing we're going to do here is actually the NCV and live test. So we're going to do the live test first. So let's go to select, put that on live. Let's get taking the lead out. Let's get that lead back in there. These actually fit in very snugly. All right, so here's the lead, the live test. Let's jam the lead in the socket and let's see what happens. I'd say we're good there. Okay, so much for that. Let's select, go back to non-contact voltage. All right, let's try the NCV and see what it does. I'd say pretty good, pretty sensitive. Yep. See if the LED above does it. Yep. No problem. All right, so that's pretty much going to wrap it up for the test on this. Let's go ahead and move on to the pros and the cons. Okay, now on to the pros and the cons of the Kaiweets HT112B multimeter. On the pros, this meter does have very good accuracy on all measurements with that one quirk. Also, the NCV antenna is very sensitive without being overly sensitive. It seems to be solidly built. I can't really find anything to fault it in that area. Seems to be put together pretty nicely. It's easy to use, especially speaking of the auto mode, which does default to 3 of the most commonly used measurements with multimeters, which is voltage, resistance, and continuity. So that was cool. It's also small, which makes this a great choice as a glove compartment multimeter or to be thrown into a tool bag, especially considering that it comes with a nice case, that's somewhat durable, and also comes with 2 sets of batteries, which is nice. You usually don't see that. You usually get 1 if you get any at all. And on top of that, a spare fuse. So that was a nice touch by Kaiweets. On to the cons. The display does tend to wash out a bit when viewing at angles. I'm sitting off to the side of it right now, and yeah, I can read it, but it is washed out a bit. The backlight does not stay on. However, having said that, they at least took into consideration that, that does annoy some people, so they did give it a 2-minute time limit. So 2 minutes, it's pretty reasonable. I mean, you don't have to turn it on constantly every 30 seconds or whatever, so that was nice, despite the fact that it would have been nice if it would just stay on. The voltage readings are accurate on this. Specifically, I'm speaking of the DC voltage readings, but they tend to waver for whatever reason. I'm guessing that's something to do with it being an auto mode, because I do not see it exhibit that behavior in DC millivolts, nor do I see it exhibit that behavior in AC voltage. So I'm not sure what's going on there. For most people, that's probably not going to matter a whole lot because it does not waver that much, and it doesn't cause it to drift. It's just kind of drifting between a fixed set of whatever it's reading. But if you are looking for more precise voltage readings, yeah, that could get a bit frustrating. So I don't know. It could be a firmware issue. I'm not sure what's causing that. But anyway, I don't care for it a whole lot personally. Another thing I don't like are the non-standard leads. However, they are at least modular, but they're not easily replaceable because the jack size is not standard. I mean, you're going to have to go to Kaiweets and hope that they have some in stock if you need replacements. So that's a minor negative, but at least they aren't permanently attached to the meter, especially for it being the size that it is. And last but not least, and I cannot stress this enough, no stand. And while in practical use, you can lay it down on a table and look at it, but I tell you what, it was a headache getting this thing to stay up when I was doing the measurements. So it would have been nice if they had included a stand or something that you could at least prop it up on, at an angle. But again, it's a minor issue. Makes it harder for guys like me who review these things to present it, but not a big deal. Okay, now on to the conclusion. The Kaiweets HT112B is a small compact multimeter that provides good accuracy across the board. Whether or not this meter really replaces the HT118A is debatable, as it does not have all the feature that the HT118A does. Specifically there, it does not have a thermal probe. It has an internal one that measures ambient temperature, but not the same thing. Overall though, this is a very well-rounded meter that would be useful on an electronics bench or as a household meter. And also, it would make a great multimeter when you are mobile, as it comes with a sturdy case and takes up very little room in a tool bag or a glove compartment. As a matter of fact, I would think that the real intention of this meter was an on-the-go kind of multimeter. That's most certainly what I would probably use this for. As a bench meter, I prefer something with a stand, so not so much. But out in the field, light duty use, not using anything category 3, category 4, yeah, it would be just fine for that. Plus it's convenient because it's small. Anyway, overall I would say I could give this thing a thumbs up. Despite the quirk that it has on the voltage, I can live with that. Some people might not be able to, but you have been warned, you have been shown, but it is what it is, But yeah, I do recommend this meter. It is a good meter, it's an accurate meter, and worthy of somebody's collection, especially if they need a meter on the go. That's definitely what I would recommend this for. Anyway, that's going to do it for this review. This is Sui778. Thanks for watching, and we'll catch you on the next one. Okay, one last thing I did want to show now that we have it put back together is the jacks on the bottom. Neglected to show that earlier. Here is your